Implementing antennas in a wireless device can be complex and time-consuming, especially when balancing performance, placement, and real-world constraints. Choosing the right antenna and ensuring it is properly integrated can make all the difference in your design. What if you could simplify that decision-making process? In this tutorial, we'll explore how to use KYOCERA AVX's Antenna Integrator Studio to identify the most suitable antennas and optimize their integration into your PCB design in just a few steps. The process begins with the PCB design. The layout can be visualized and adjusted in both 2D and 3D views. The board shape and dimensions can be defined as needed. In this example, the PCB length is set to 125 millimeters and the width to 45 millimeters. Restricted zones can then be added to reflect placement constraints. In this example, we are simulating the placement for 2 microcontrollers. The first restricted area is defined at 15 millimeters on the x-axis and 12 millimeters on the y-axis, with dimensions of 10 by 7 millimeters. A second restricted zone is added at 100 millimeters on the x-axis and 20 millimeters on the y-axis, with dimensions of 5 by 12 millimeters. With the PCB layout complete, the antenna requirements can now be defined. This design requires 2 antennas, one for 5G and one for GPS. The 5G antenna is configured first and named accordingly. Linear polarization is selected, and the clearance is set to any for flexibility between on-ground and off-ground. The appropriate radio protocols are then defined among the different options available, including 2G, 3G, 4G, 5G, BLE, GNSS, LoRa, and more. In this case, EMEA is selected, with North America added for broader compatibility. The antenna is then added to the configuration. Next, the GPS antenna is configured. Right-hand circular polarization is selected, along with GNSS as the radio protocol. Clearance remains set to any. Unnecessary frequency bands are removed, retaining only the GPS band. After that, a key decision metric for the optimization is selected. Available options include efficiency, price, and return loss. For this example, efficiency is chosen as the most important parameter for optimization. The analysis can then be launched, with all parameters remaining editable at any time. The tool automatically positions both antennas while respecting the defined constraints and recommends the most suitable KYOCERA AVX antenna solutions. The recommended antennas are displayed with detailed information. For example, the 5G configuration suggests the 1004975 antenna. Supporting resources such as adaptation circuits, datasheets, DXF files, S parameters, simulation files, and more are readily accessible. Performance metrics, such as efficiency, can be analyzed, with results displayed in percentage or decibels. Peak gain can also be reviewed. Return loss can be examined with the same level of detail. The visualization tools allow zooming into specific frequency bands, inspecting precise values, and resetting the view as needed. Radiation patterns can be visualized in 3D without requiring complex simulations. The model can be explored from multiple angles, is fully interactive, and can be saved for further use. Frequency can be adjusted, for example from 2110 MHz to 2500 MHz, to observe how the radiation pattern evolves. The model remains fully interactive for detailed inspection. The same analysis can be applied to other configured antennas, such as the GPS antenna. Frequency adjustments allow observation of performance variations, and once requirements are validated, antenna details can be reviewed. Once ready for prototyping, samples can be sourced online. KYOCERA AVX Antenna Integrator Studio. Faster decisions, better performance, less guesswork.